Hey, how's it going, everyone? I hope the test on Monday went well. And if you're watching this video and that is not turned in yet, please stop watching this video and turn that in right away. Alright, so I'll be trying to get that back to you guys by Monday. What I'm going to do is I'm going to post a rubric on Google Classroom that will have the number of points for each question, and I'll tell you how many points you got for each question. Alright, so if you lost any points and you're not sure why, just let me know. Just send me a message asking why did I lose points on question number 10, for example, because the only feedback you're going to be getting is the number of points you got on that question. Alright, so if you have a question on why you lost points on something, just let me know on Google Classroom. Alright, so today we're going to be solving quadratics by taking square roots. So let's practice simplifying these square roots or radicals first. Right, this was from Friday, that lesson Friday, we learned how to simplify radicals. So take a minute or two and pause this video and try this warm up. Alright, so remember, when we're trying to simplify a radical, we're trying to look for the largest blank that divides into the radicand. So again, the radicand is the guy underneath the square root. So if it's a 42 here, the number 42 is the radicand. Right? I'll actually leave the 42. Right? That's the radicand. So we're looking for the largest perfect square that divides into the radicand, because we can take the square roots of perfect squares. So anytime you're doing one of these problems, it makes sense to list out the perfect squares. So I like to go up until 12, because that's usually what you go up to in the times table. 7 times 7, 8 times 8. Right? And the way I'm getting these numbers, again, just 2 squared, 3 squared, 4 squared, etc. 5 times 5, 6 times 6, 8 times 8, 9 times 9, 10 times 10, 11 times 11 is 121, and 12 squared is 144. Right, so these are some of the perfect squares. And when we do these, we look for what's a perfect square that divides into 45. Well, that is 9. 9 times 5 is 45. So I make this the square root of 9 times the square root of 5 is the square root of 45. And that's a perfect square. Square root of 9 is 3. This becomes 3 square root of 5. Alright. Next, when you have something times your square root, right, kind of just ignore that something for now. I'm going to break down square root of 48 into 16 and 3. And now I'm going to bring down this negative 3. Right? If you used 4 and 12, by the way, that also works. You're just going to have an extra step. But going back to here, radical 16, that's going to be 4, right, times radical 3, and then negative 3 times positive 4 is negative 12. So you can only multiply numbers that are not underneath square roots together. Right? Make sure you're not doing like 4 times 3 here or something like that. Or sorry, 4 times this 3, because this 3 is underneath a square root. So you're only allowed to multiply things that are not underneath square roots together, just like 3 times 4. So that's negative 12 square root of 3. Right? This one we have square root of 2 times the square root of 18. So let's simplify the square root of 18. I think a 9 divides into 18, so I'm going to make that square root of 9 times square root of 2. Right, square root of 9, that will become 3. I'm going to bring down this square root of 2 in front. So square root of 2 times 3 times another square root of 2. And I'm multiplying all 3 things together, so why don't I multiply square root of 2 and square root of 2 together first? Do you guys know what square root of 2 times square root of 2 is? That is going to be the square root of 4 times 3. right? And the square root of 2 times square root of 2 is 2. And that's 2 times 3, and that's 6. So just like we're allowed to multiply numbers outside square roots together, we can multiply numbers underneath square roots together. So the square root of 2 times square root of 2 is the square root of 4. And knowing that, we actually could have just said in the very beginning, oh, square root of 2 times square root of 18, they're both underneath square roots. We can multiply them together, so you get square root of 36. And what times itself equals 36? 6. So a lot easier that way. But if you didn't see that and you simplified square root of 18, right, you still get 6. Over here, 288 is a big number. So I'm going to look at my list of perfect squares, starting with the biggest one because we always want the largest. Right? If you don't get the largest, you can still do it. It's just more steps. But starting with the largest, 144 goes into 288. And it's actually 144 times 2 is 288. So square root of 144 times square root of 2 is square root of 288. Alright, square root of 144 is 12 times the square root of 2, all divided by 6. And then 12 divided by 6 equals 2. So this is 2 square root of 2. Alright, also as part of our warm-up, just solving these equations for x by, well, setting equal to 0 and then factoring using the zero product property. So I just want to do these real quick. Right? Subtract 16 on both sides. That's a difference of 2 perfect squares. And when we're solving, right, we want solutions for x. So when we tee it off here, we're going to get x equals -4 and x equals +4. Alright, next one over here. We got to set this equal to 0, so I'm going to subtract 25 from both sides and get x plus 5 in parentheses squared minus 25 equals 0. I can't really factor this yet because it's not in standard form. So I could expand this, right? X plus 5 squared is x plus 5 times x plus 5. When you FOIL and distribute and everything, you're going to get x squared plus 10x plus 25, right, from that. Make this a different color. Let's go with green. And we still have this minus 25 over there. That's equal to 0. So combining like terms here, we can combine the 25 and minus 25. We get x squared plus 10x equals 0. Now it's in standard form. Now we can factor. So the GCF here, it looks to be a x. They both have an x in common. So it's x times x plus 10 equals 0. Teeing this off, we'll get solutions of x equals 0 and x equals -10. And lastly, this one, it's a trinomial. What multiplies to 3 and adds to 4? Well, 3 times 1 is 3, and 3 plus 1 equals 4, so that's how it factors. Tee it off, we get x equals -3, x equals -1. Alright, so quick bit of review there, but for these equations we just solved, could we solve them a different way? So you actually probably already know there's a way to solve these problems. It's probably your first instinct. But when you're squaring something, right, the opposite of squaring something is square rooting it. So we can square root both sides, and then we should get x equals 4. But let's think about this for a second. Is 4 squared the only thing that gives us 16? Right? We know 4 is a solution because 4 squared equals 16. But is there another number squared that equals 16? Right? If you're thinking about it, I'll let you know the answer is yes. There's something else squared that equals 16. And we need parentheses for the second answer. So think about it. But isn't negative 4 squared also equal to 16? Right? Negative 4 times negative 4 also equals 16. So, and we know that also because, let's take a look. Didn't we get two solutions here? Right? Negative 4 squared and positive 4 squared equals 16. So when you square root both sides like this, right, you always need to include a plus or minus as part of your answer, right? Because the answer could be positive or negative 4. So there's a special there is a special symbol we use to show it could be positive or negative. All right. So anytime you write the square root yourself, so I square rooted both sides. When you square root both sides, you need to include a plus or minus over here in front of the square root. Right? That gets introduced into it when you square root both sides. So x doesn't just equal 4, x equals plus or minus the square root of 16, which is 4. And you can leave your answer just like that, that's fine. But know that this plus or minus symbol in front, right, this is really saying that x equals positive 4 and x equals negative 4. All right. Next one. So just like before, right, we have something squared. In the previous one, we had x squared equals 16. Well, now we have this guy in parentheses squared, x plus 5 squared. So what's going to happen if I take the square root of x plus 5 squared? Well, if I take the square root of that, the square root and the squared symbol, right, those two guys will cancel each other out. And I'll be left with just an x plus 5. Right? If I square root the left side, I also must square root the right side. And remember, when you square root both sides, you need to introduce a plus or minus. So when I square root both sides, I need this plus or minus here. Let me pick a better color. Right? That's really important. Do not forget the plus or minus. And I get x plus 5 equals, so square root of 25 is plus or minus 5. And now I'm going to subtract 5 from both sides. But before I do that, well, actually, I'll subtract 5 from both sides first. Alright, so I'm going to minus 5 and minus 5. So don't try to add these two things together because that's not just a 5, that's a plus or minus 5. So the way I'm going to write my answers for now is x equals negative 5 plus or minus 5, right? I just moved the negative 5 in front. Or you can also write plus or minus 5 minus 5. It doesn't matter. But now we need to think of both solutions. Remember, this plus or minus means x could equal negative 5 plus 5, or x could equal negative 5 minus 5. So what is negative 5 plus 5? That's 0. And what's negative 5 minus 5? That's negative 10. So those are my two solutions. And isn't that what we got over here? Right, this was a bit more work, I think. But we got the same answers by factoring, right, or by taking square roots here. Right, so for this last one, we actually cannot solve this problem yet. Right, for example, what some people might try to do is make this equal negative 3 and then square root of both sides. But know that you can't just square root the x squared, right? You have to square root both sides of the equation. And so that would look like that, and you have no idea how to square root something that looks like this. So when the x squared, or the something squared, guy is not by itself, you can't square root both sides here. So I'm going to say we can't solve this. We can't solve using square roots when a question looks like this? Well, at least not yet. We will learn how to do this using square roots, but not now. So for now, just know you can't square root both sides. When you have both an x squared and an x in the equation, because you can't just take the square root of this part and ignore the 4x. And if it's not just something squared, we don't know how to take the square root of that. Alright, so I have some equations here that I want us to solve by taking square roots. So x squared equals 5. So this guy is by itself. I'm going to square root both sides. The square root of x squared is just x. Right? Again, the squared and the square root cancel each other out. They're opposite operations, just like multiplication and division or addition and subtraction. And when I take the square root of 5, well, the square root of 5 doesn't simplify. It's not a nice number, right? It's not a perfect square. So I just leave it as the square root of 5, but don't forget I need a plus or minus. And that is my answer. All right, and again, this means x is both positive the square root of 5, and x is also negative square root of 5. Alright, next, same thing, we're going to square root both sides. Square root, square root. X is going to equal, don't forget the plus or minus, square root of 27. Alright, but in this instance, I can simplify this radical. Right, just like in the warm-up. We know square root of 27, I can break that down into square root of 9 times the square root of 3. So x is actually equal to plus or minus, the square root of 9 is 3. You can say plus or minus 3 times radical 3. So just going to write a little note here. Make sure to simplify any radicals if possible. Alright, so the answer doesn't always have to be a nice number. You could have radicals left in your answer, and that's completely fine. It just means our x values here are irrational. Right? As a decimal, they go on forever with no pattern. But you don't ever want to write the decimal. You don't want to type this into your calculator. Right? You want to leave your answer just like this. Right? How about something like this one here? So we can't just go ahead and square root right away because I don't know how to take the square root of 4x squared minus 11. Right? So the idea is, the reason we're allowed to square root is because square root is the opposite of squaring something. So what we want to do here is get the squared guy by itself, or the x squared by itself. So that's really the goal. So kind of just pretend like that's our variable, like that's an x, right? If the question were 4x minus 11 and you wanted to solve for x, well, wouldn't you add 11 to both sides? And then we would get 4x equals 36. And then wouldn't you divide both sides by 4 and get x equals 9? So that's the exact same thing we're going to do here, except it's not an x, it's an x squared. So we're kind of just solving for x squared first, getting that by itself. Right? And once we have something squared equals something else, well, we know we can solve this now by taking square roots. And in doing that, we get x equals, do not forget the plus or minus, right? It's plus or minus the square root of 9, which is plus or minus 3. Alright, on this next one, if we're solving using square roots again, we actually do not want to expand this, right? We would expand this if we're trying to factor it. We would get it into standard form. But using square roots, all we have to do is get the squared guy by itself, right? Because it's going to end up looking like this one, for example, right? Once we have a squared guy by itself, we can square root it, and then we can solve. So in this problem, we're trying to get this by itself. So I'm going to add 281 to both sides first. Right? We're just following reverse PEMDAS. 3 times x minus 3 in parentheses squared equals 300. We can divide both sides by 3 now. That cancels. And we get in parentheses x minus 3 squared equals 100. And now we can square root both sides, right? Because we have something squared equals 100. So again, the idea is if you have something squared and you take the square root of it, what you get is equal to something, right? Because that and that, again, cancel out. So the something in this problem right here, that is x minus 3. So when I take the square root of x minus 3 squared, I get just x minus 3. Right, and that's square root of 100, that is 10. Do not forget your plus or minus. Right, at this point you can add 3 to both sides, or you can split it up into 2 equations right now. It's really up to you. I like adding 3 to both sides first. So adding 3 to both sides, we get x equals 3 plus or minus 10. Right? Or if you want, you can say plus or minus 10 plus 3. Right? It doesn't matter where you put the plus 3. So if you put it on the back, we get 2 solutions. We get x equals, that's a plus or minus 10, so it could be a positive 10 plus 3, or x could be a negative 10 plus 3. And solving both, we get x equals 13 and x equals negative 7. Alright, so the steps we followed there to solve using square roots is we are going to isolate the something squared expression. Right? Once that is by itself, we're going to square root both sides. When you square root both sides, do not forget the plus or minus. And if it's not a perfect square, you're going to have to simplify the square root and then solve for x if needed. Right? What I mean by solve for x if needed is this stuff over here. So I will be doing all 8 examples here. All right, your homework will be pretty similar to this. So if you would like, you can go ahead and pause the video and try some of these problems, or try all of the problems actually, and check your answers after with this video. All right, so here we go. Letter A, we're trying to get the x squared term by itself, the something squared. So we're trying to get this by itself. We're going to minus 3 on both sides, get x squared equals 81. When we square root both sides, square root, square root of x squared is x equals, don't forget the plus or minus, the square root of 81 is 9. And that's it. All right, letter B, same thing, we're trying to get x squared by itself. So I'm going to minus 12 on both sides first, and get x squared over 5 equals 20. Multiply both sides by 5, x squared equals 100. And then square root both sides. Alright, don't forget the plus or minus when you square root both sides, because x can be both positive 10 and negative 10. Alright, so you know what, I'm actually going to skip C and D. I'll come back to those at the end because I want to get to a couple more interesting ones. Alright, let's do letter E. This is a good one. 3x squared equals minus 12 on both sides. We're going to get 63. Then we're going to divide both sides by 3. We're going to get x squared equals 63 divided by 3 is 21. And now when we square root both sides, we have plus or minus the square root of 21. But 21 is not a perfect square, so we have to simplify the square root. So is there any perfect square that divides into 21? Well, 4 doesn't go in, 9 doesn't go in, 16 doesn't go in, and then 25 is bigger than 21. So we can't simplify it, but just because you didn't get a nice answer like 2 or 4 or 0 or 11, right, doesn't mean it's not an answer. Our answer in this case is irrational, right? X is plus or minus the square root of 21. And you leave it just like that. Right? On letter F, when you have more than one thing squared, I'm sorry, I shouldn't say more than one thing. When you have something squared, but the something is more than just x, right? That's still fine because we can still take the square root of it, and those will cancel out. We're left with just x plus 3 equals plus or minus 4. I'm going to subtract 3 on both sides. X equals plus or minus 4 minus 3. Right? I think I put the negative in front the first time. Right? Doesn't matter. But we get two answers. X equals positive 4 minus 3. And x equals negative 4 minus 3. So we get x equals 1 and x equals negative 7. Alright, letter G here. We're going to divide both sides by 2. Again, we're trying to get the something squared by itself first. So dividing both sides by 2, we get 50. Now we have the something squared by itself, so I can square root both sides. And this becomes x minus 1 equals plus or minus the square root of 50. So this is one where you have to simplify the square root. So the square root of 50, I know can be broken down into 25 times 2. Right? So I can say plus or minus the square root of 25 times the square root of 2. And that's going to become plus or minus, the square root of 25 is 5. So plus or minus 5 square root of 2. So x minus 1 equals all of that. And now I'm going to add 1 to both sides. So x equals, if I just add 1 to both sides, right, I can put the plus 1 at the end like that. Plus or minus 5 square root of 2 plus 1. So we cannot add these together, right, because this has a square root of 2 with it, this has no square root of 2 with it. Right? You can't just add a number with an irrational number like that. So do not make this 6 square root of 2 and negative 4 square root of 2. Because they're really not like terms that you can combine. And if you wrote your answer like this is fine. But when I add 1 to both sides, I'm actually going to put the plus 1 in front because that's usually how it's going to be written. So my final answer is going to be x equals 1 plus or minus 5 radical 2. And I know that probably makes a lot of you very uncomfortable seeing an answer written like that. But it's actually the nicest way of writing this answer, right? And again, this means x is equal to 1 plus 5 square root of 2, and also that x equals 1 minus 5 square root of 2. So you can leave your answer with the plus or minus, but you should also know that it's really saying we have these two separate answers. Alright, and one more. This one over here, we're going to add 52 to both sides. That's 5 times x plus 6 in parentheses squared equals 450. Dividing both sides by 5, we get x plus 6 squared equals 450 divided by 5 is 90. Now I'm going to square root both sides. I'm not going to forget the plus or minus. And we get x plus 6 equals plus or minus. Right, how can we break down the square root of 90? I can break it down to 9 and 10, which is 3 radical 10. So plus or minus radical 90 becomes plus or minus 3 square root of 10. I'm going to minus 6 on both sides now, and I'll write x equals, and again, you can put the minus 6 at the end when you minus 6 on both sides, but typically it's going to be written with the negative 6 first, plus or minus 3 square root of 10. And that's your answer. Again, I'm just going to write it out with both the positive and negative version, at least in the beginning, just so we can really see that there's two answers, because a lot of people forget that this actually means there's two separate answers, plus 3 and minus 3. And that's that. And that is how you should write your answer. Do not type any of that into a calculator, right? But you should know that these are equal to some decimal values. So actually, just for this case, I'm going to type it into the calculator, just so we can see that this is just equal to a number that is about 3.48683 something something something, right? And if you typed in negative 6 minus 3 square root of 10, you'd get negative 15.4868 something something something. Alright, so that is what we're saying. The answers are for x. But this is really what it means as a decimal approximation. But we don't want to write our answers this way. We leave it in the exact form. Right, and I'm going to go over the two questions I skipped real quick if you want to take a look at these. So this one, 6x squared equals 48, subtract 12 on both sides. X squared equals 48 divided by 6 is 8. And then we take the square root of 8. We get x equals plus or minus the square root of 8. Square root both sides. Simplify that square root, we get plus or minus 2 square root of 2. Alright, on this one, subtract 45 on both sides. We get negative x squared over 3 equals negative 30. Yep, multiply both sides by 3. We get negative x squared equals negative 90. Again, I want to get the x squared by itself, so I have to get rid of that negative also. So I'm going to multiply or divide both sides by negative 1, right, to get rid of the negative. And that will become x squared equals positive 90. Square root both sides, x equals plus or minus the square root of 90. And x equals, simplifying that square root, it's going to become 9 times 10. So square root of 9 is 3 times the square root of 10, plus or minus. Right, and that's going to be that. So, as always, any questions, just leave a comment, and I will get back to you guys. Alright, and alright, see you guys later. Bye-bye.